Welcome to today's lesson on cloud security and monitoring. In this video, we'll explore the key concepts of cloud security monitoring techniques and give you real-world examples to better understand how these technologies work together to protect cloud environments.
Software-defined security. First, let's talk about software-defined security, or SDS. SDS is a security model where the entire security framework in a cloud environment is controlled by software. Imagine you have a security system that automatically detects potential threats, manages access, and ensures your data is safe, without much human intervention. That's SDS for you. For example, companies can use SDS to automate the monitoring of their networks and restrict access to sensitive areas based on policies.
Principle of least privilege, PLOP. Next up is the principle of least privilege, often called PLOP. The concept is simple. Users or processes should only have access to the resources they need to perform their tasks. No more, no less. This minimizes the risk of data breaches or unauthorized actions. Think of it like giving an employee a key to their office but not the entire building. Only specific doors are accessible to them.
Identity and Access Management, IAM. Identity and Access Management, or IAM, is a critical framework to enforce the principle of least privilege. IAM ensures that the right users have access to the right resources at the right time. For example, when logging into a system at work, you're required to authenticate yourself. IAM governs this process by setting policies, managing user identities, and deciding who can access certain applications or services. IAM components include users, groups, roles, and policies.
Multi-factor authentication, DA. To further enhance security, multi-factor authentication, or MFA, is widely used. MFA requires users to provide two or more pieces of evidence to verify their identity before gaining access. Let's say you're trying to log into an account. First, you'll enter your password, something you know, but then you'll also need to enter a code sent to your phone, something you have. This additional step helps secure sensitive information. Federated Identity and Single Sign-On, SSO. Now, let's talk about Federated Identity and Single Sign-On, or SSO. Imagine if you had to log in separately to each service you use. Pretty inconvenient, right? SSO solves this problem by allowing you to log in once and access multiple systems without the need to log in again. For example, when you log into a cloud service, you can use that single identity to access email, data storage, and even third-party applications seamlessly.
Encryption. Encryption is another important aspect of cloud security. There are two types, client-side encryption and server-side encryption. Data is typically encrypted in 3 stages: data in use, data in transit, and data at rest. This ensures that even if data is intercepted, unauthorized users cannot access it.
Security risks and threats. While cloud security has advanced, there are still risks and threats. Poor access management, data breaches, and insecure APIs are some of the biggest challenges. One common issue is account hijacking, where malicious actors gain control of cloud accounts due to weak security practices.
Cloud monitoring. Cloud monitoring is the process of observing and managing the workflow of cloud services. Monitoring ensures that everything from websites to applications is running smoothly. Tools like Datadog, Azure Monitor, and Amazon CloudWatch help track performance and uptime. For example, if a server goes down, cloud monitoring tools will generate alerts, allowing IT teams to take action before any significant downtime occurs.
Metrics, events, and logs. Metrics, events, and logs are the backbone of monitoring. Metrics provide raw data such as CPU usage, events capture actions when something happens, and logs provide detailed information on system activity. This data is crucial in diagnosing issues and keeping cloud environments secure.
Alerts. Lastly, alerts are the reactive components of a cloud monitoring system. Alerts are triggered when specific conditions are met, such as a system failure or unusual traffic. Companies rely on these alerts to respond to potential security incidents in real time. In summary, cloud security and monitoring are essential components of modern cloud infrastructure. From software-defined security and IAM to multi-factor authentication and cloud monitoring, these tools work together to protect data and ensure smooth operation. Thanks for watching, and be sure to like, subscribe, and hit the notification bell for more tech lessons like this.